Let us solve the exercise number 1 in the part B of CMA lab. In this exercise, we are supposed to create a web page using HTML5 canvas element. We are supposed to show a clock that changes the time as done by the analog clock. We have to show the second, minute, and hour pointers. And this is the sample image that they have given. And we are supposed to create the clock as shown here. I've already created one clock, and let's see the output of this. This is how it should appear. And let's try to create this same clock using the HTML canvas. I have with me the NetBeans. You can use any other ID, VS Code or anything for your convenience. But I'm going to use the NetBeans. You can use any other ID also. Let's start with the HTML5 JS project. And I'm going to give it as a clock app. You can give any other name also. I don't want any template. Also, I don't want to use any of the JS and JSON files. Let me click finish on it. And the NetBeans is going to create a template for me, and I'm going to remove this first remark statement, which is of no use to me. Also, I'm going to give a title for this one as clock. And we have a div with us, and let's try to put a canvas in this div. And so I'm going to start with the canvas, and I'm going to close that canvas. I'm going to set the width and height of the canvas so that it's going to appear like a square rather than a rectangular shape, so that it is easier for us to get the circular option there. So I'm going to go and I'm going to give it a ID to this particular clock first. Let me call it as a clock because I'm going to use a JavaScript and I want a reference to that. Also, as told, I'm going to give a width of 400 and height of 400. So this is what I have done. And let's keep the remaining thing as it is. Let's try to get the hold on to the CSS first. So I'm going to start with the style. The CSS is required because we want to get the blue colored circle here. So this is the done using CSS. So let's go ahead and let's get that thing. And we know very well, in order to get that thing, we have to have the border with us. So let's start with let's get hold on the clock first and then start doing it. So I'm going to do it on the canvas itself, and you notice that the canvas has the same ID, and I'm using the same ID of the canvas. And let's start with the border, and I'm going to get the border, and let me say I'm going to take a 8-pixel border, and I'm going to make it a solid border, and let me take the color as a blue color. So that being done, if I save and just run it just to see how it's going to look like, and this is what you're going to get it, but this is in square because I've taken 400 cross 400. Let's convert it into a circle, and we know very well how do we do that is we are going to go and we are going to say border radius. Okay, so let's go with the border radius. I'm going to set it as 50%, and let's press enter, and I'm going to save it. I'm actually saving it. So if you didn't get it, how I'm getting this updated is I press Ctrl S. You are already familiar with this Ctrl plus S. I'm saving it. So I do it manually without telling anything. I'm doing it. But if you want to get the output, you just press Ctrl S and come back to this one, and you will be able to see the circle here because it's a 50% square on 50%. Let me fill the background color as white. So even though it is white, but just to be very specific, I'm going to do that part. Now, some of you may be thinking, why don't you set the width and the height directly here? Why are you setting the width here on the tag rather than setting it at the CSS? I'm going to show you what happens if you try to set it on the CSS later, and I'm going to explain to you why you should not do that thing. As of now, let you just take it for granted that I've set it here, but if you set it here, as of now, if you set it here, you're not going to get the result that you expect to see. Okay. Now, this is what we are supposed to do it, but this clock is on the one side. So let me go to the body itself. I'm going to go to the body. That is my body tag that I'm using. So this is the tag that I'm using. See, body tag, directly I'm setting it, and I'm going to center the content of the body tag. So I'm going to say text align, and I'm going to say center. Control S, and we are there at the center. So this is what we have done. Now what we are supposed to do is we are supposed to get this marking first. So we are supposed to get this marking, and that has to be done using the JavaScript. So let me go ahead and let me put a script here. I will start with the script, and I will not this prototype. I'm going to start with the script and script. Okay. First of all, let me get the hold on this clock itself. So how do you get the hold on this clock? I'm going to create a variable here, and I'm going to call this as clock. And how do you get it? You go to the document element, and you will say get element by ID, and you're going to get the hold on it. So what you've done is you got the reference to this element, and you are calling it as clock. You can call it with the canvas, you can call it with any variable name. That's just a variable name. And then we know very well we need a context. Let me call it as ctx. How do you get it? You just go to this clock, and you say get context, and let's get context, and I'm going to get the 2D context here. So that's done. So you have the context with the two-dimensional context, and I'm going to start with the function. So let's start with the function. I'm going to say draw markings. So that is this function. So this function, I'm going to use it to draw the marking on the clock here. How do you get this marking? So that is interesting one. So this marking, if you extend it, you're going to see that this is actually you're drawing lines like this. This is all are lines there. So all of them are lines that you have drawn. Okay. How do you draw a line? For this, we are going to use some mathematics. So in mathematics, you know very well what is sine theta and cos theta. So sine theta is nothing but opposite by hypotenuse, and the cos theta, these are only things that are required, is the adjacent by hypotenuse. Okay. So if you represent it on a circle, that is generally you represent this triangle in a circle, then you know very well this hypotenuse that you see here is the radius of the circle. Okay, that's going to be the radius of the circle. And how do you get this value? So any point on the radius, on the circumference of the circle, any point on the circumference of the circle, if you want to see any point on the circumference of the circle, this circumference, any point, you have to represent any point using x comma y. You know very well. So any point is represented using x comma y. How do you get the values of x comma y? So you know very well. So what is the value of cos theta? So cos theta is hypotenuse by adjacent side. Okay. So if you multiply the hypotenuse with the cos theta, you are going to get the adjacent side. So you are going to get this value. Okay. So in other words, you look at this one. If you multiply cos theta with the hypotenuse, you're going to get the adjacent. So if you say, I'm going to say hypotenuse into cos theta, let's say cos theta, okay, we just represent cos theta, okay, equal to, because I can't get, I don't know how to get that theta on the keyboard, but let's say you get this adjacent side. So hypotenuse into cos theta, you're going to get this adjacent side. Okay. Now, what is hypotenuse? I have already told you. In a circle, hypotenuse is the radius. Okay. So if I go back over here and if I represent it like this, so this is the radius. Okay. So this is the radius. This is the radius of the circle. So if I say the radius of the circle into cos theta, let's say this is cos, assume that this is theta, you are going to get the adjacent. What is this adjacent? Adjacent is this distance. What is this distance? This distance you know very well. This is the x value. So x of this point, this is the x value that you are going to get. So you are going to get the x value. In the same way, x value. In the same way, if you do radius into sine theta, okay, assume that this is theta, you are going to get the y value. So you know very well, radius into sine theta, you are going to get this opposite side. Okay, so this, what is this opposite side altogether? This opposite side is the distance from along the y-axis, and that is what is the y-axis. You're going to get this y-axis. So if you multiply hypotenuse into sine theta, okay, you're going to get the opposite side. And what is this? So opposite side? Opposite side is nothing but the y value. So you get this y value, you get this y value, and you get this x value by saying cos theta, okay, and sine theta. In general, this is because they have taken the radius of the circle as 1. Suppose if the circle has any other radius, then how do you do that thing? You are going to say r cos theta, comma, r sine theta, okay, r sine theta. You are going to get the value of x and y. So this is x value is r cos theta and y value is r sine theta. This is what you are going to get. So any point on the circle, you can get it using r cos theta and r sine theta. So you get to know that thing. So as this theta value changes, as the theta value changes, as this theta value changes, value of x and y changes. So for example, if you look at the one, okay, if you look at here, so let me show it from here. Let's say this one has to be, it is it's a GIF file. Okay, you notice that the value of theta is changing as the value of the theta changes. As the value of theta changes, the value of x and y are changing. So constantly this x, y values are changing like anything. So you start with the 0 degree from here and you go up to 90 degrees. So as the value of theta changes, you notice that the theta is changing. Now I'm going to start, this is going to start from the beginning. So this is 30 degree. You get some value x comma y. This is 45 degree and you know root 2 by 2 and 60 degree and so on and so forth. So as the value of theta changes, you are going to get different values for the sine and cos value. So this is what you are going to get it, and this is what we are going to use in our circle. So we are going to draw from the center, we are going to draw one line. So this at 0 degree we are going to draw a line, at some other degree 20 degrees we are going to draw a line, 30 degrees we are going to draw a line, 45 degrees, 60 degrees, 90 degrees. So as the value of theta changes, so as the value of theta is changing, we are going to get different points on the circumference of the circle. This values are given by x comma y, and you know very well x is given by r cos theta, and y is given by r sin theta. So radius into cos theta and radius into sin theta. This is what we are going to do it. Now the first thing that we need to get is we need to get the angles. So we need to get the different angles. You know very well angle from here to here, the angle is 360 degrees. Okay, but 360 degrees is not the angles we want. We don't want all 360 degrees values, but what we want is, we know very well in a clock there are going to be 60 points will be there. So 1 2 3, so this is 1 2 3 4 5 6, all the this minutes or second, whatever you think of, this is going to be 60. So there is going to be 60 divisions will be there. Okay, so there are 60 divisions are there. So this you are all familiar with that. What is the total angle that this circle is going to take? So this circle, you know very well, if you take this as the circle, so full angle is 360 degrees. So this 360 degrees has to be divided into 60 units, because we want 60 lines. So this 1 2 3 4 like this, 60 lines are required. So we want 60 divisions for that. So let's start getting the angles now. So I'm going to use a for loop for here. So for variable I is equal to 0, from 0 degrees up to 60 degree. Remember 60 is not there. 60 means you are going to come back to the 0 again. So in the clock, you know very well, in the clock this is 0, okay, then 1 2 3 4 5 6 and so on, 59, and then again 60 is not there, but it is going to be 59 altogether, from 0 to 59, that is I less than 60. We are going to increase the I value by 1, I plus plus. So we got this for loop here, and in this particular for loop we are supposed to get the angle. So how do we get this angle? So let's get this angle. So let's get this angle. How do we get this angle? You know very well, angle is whatever I value is there. So I value is changing. So what is the meaning of saying I value is changing? I is this is 0 1 2 3 4 5 6 and so on up to 60 will be there. So for this 360 divided by whatever is the value of I. So when I value is 1, this you are going to get. When I value is 2, this is the next one. I value is 3. So as the value of I changes, you're going to get different angles there, and that is what we are going to use there. So I by 60 into 360. However, you must understand here we are talking about mathematics, and mathematics people don't use the degrees, rather they use something called as radians. Okay, so what is the relationship between the radians and the degree? So 2 pi radians is equal to 360 degrees. So this is what you must understand. So 360 degrees is 2 pi radians. Okay, that's only one formula, you just remember it. So what is pi? Pi radians is 180 degrees. Remember that thing. Okay, so 2 pi means 360 degrees. So this whole 360 degrees that you get is 2 pi radians. So instead of writing it as 360 degree, I am going to write it as 2 pi radians. That how do you write it? 2 into, I will use the math library here. So I'm going to say math dot pi. So this is, I'm going to get a different angle. So as the value of I changes, I'm going to get the different angles. Now my question is, I need to find the center of this circle. So I have to get the center of this circle. How do I get the center of this circle? Remember, this is the 400 cross 400 pixel that you have used. This is 400 cross 400 pixel. Divide the width by half. So this whole width is there. This is 400 pixel. Divide it by half. You get this On the other side also 400 pixel is there, divided by half, you get the what we call it as the center of the circle. So let me get the center of a circle, because I'm going to use the center of the circle for many other calculation also. Let me get this center of this circle. So I say center x value is nothing but my clock, and I'm going to get the width by 2. Okay, similarly I'm going to get the center y is equal to my clock dot height by 2. Also I have to get the radians. Now you will say that the radius of the circle is same as the width of the this value, that is 200 pixels. So suppose if you get this one, let me do that thing. Now what I have done is I have divided it into half. This width I have divided it into half. This whole thing is the your entire circumference value that you are taking, but I want the half of it. Now if you divide it by half, what you get is the radius of the circle, but I don't want the radius as a full length from here to here, because if you look at this clock, the it is not touching these. If you look at these things over here, it is not touching. There is some small gap is there, so I'm going to get that gap there. So I'm going to go over here and I'm going to say constant. I'm going to say radius is, okay. Same thing, I'm going to say clock dot width, okay, clock dot width by 2 minus 10 pixel, slightly lesser than that. So what I am doing is I am not taking the, let's go here, I am not taking from the center, I will not touch the entire circle. I'm going to give some gap here, so that in the demo that they have given, there is small gap is there, so that 10 pixel gap I'm going to give there, so that it will not touch the value there. Now let's come back to the story. Now how do we get these values? So I got the angle there, I got the angle there. So let's draw a line. Okay, so let me fix the let me do this one constant, and I'm going to say why to say constant. Let me go to this canvas itself, that is the context, so ctx, and I'm going to say line width, because I'm going to draw a line there. So I'm going to say line width is, I'm going to just take 6 pixel as the line width. Also I'm going to take the color as black color. Okay, so I'm going to say ctx dot, and I'm going to say stroke style. I'm going to say stroke style is equal to, let's say, black. So why I have taken the stroke style as black is because you know that these all markings are coming in black color. So I have taken it as the black in color. Let me go and I'm going to say ctx dot begin, and you know very well, whenever you want to start with something, you say begin path. You start drawing this one, and I'm going to go to the center. Remember, I don't know where is my location in this thing. Where is my location? I'm going to go to the center. From the center, I'm going to draw the lines there. So I'm going to go to the center. How do you go to the center? I'm going to say ctx. First of all, let's go to the context, and I'm going to say move to, and I'm going to say move to the center cx and cy. This is my center, not xy. Cx cy, that's the center. I've already taken this center. Cx and cy are the center of the circle. So I'm going to go to the center of this circle. I go to the center of the circle. Then I'm going to go and give me 1 second. Okay, I'm going to go to the center of the circle, and then I'm going to go up to the radians. How do you go to the radians? I'm going to say ctx dot, and I'm going to say, I'm going to draw a line there. I'm going to say line 2, and I'm going to say from the center. Remember, I'm going to start from the center. This is from the center. I'm there at the center. I said move to the center, CXCY. From there, I'm going to draw a lines there. So line from the center to the radius value. So this radius value, whatever you have, I'm going to go there. From the center, so you are there at the center. From the center to the radius, I'm going to draw the circle. So from the center plus what is the value? So you know very well. How do you get it? Math dot cos of the angle. Okay, cos of the angle into radians. So you know r radians. You can say math into the cx into radians, cos into radians, or radians into cos. It is one and the same. Okay, you are going to say radius. Okay, r cos theta. This is r cos theta. Similarly, into math dot sine r sine theta. You're going to say r sine theta. So this is sine theta into r. R is nothing but your radius. Okay, so that is done. And you know very well, if at all you want to draw a stroke, you just say ctx dot and you say stroke, and that is done. So you have drawn the stroke there. Let's look at how it's going to appear. Okay, so did I saved it? Okay, now the thing is, it's not going to do anything because I'm not calling this function. So let me call this function. I'm going to go slightly down here after this function. So after this is the function, from here to here is the function. I'm going to go here and I'm going to just call this function, so that this function is called, and you should see the circle. Okay, but I am not able to see the circle there. Okay, what might have gone wrong? Now the thing is, you run like this during the examination or during the lab, you run this and you don't see any error message. So when you are working with your C programs, if you have missed a semicolon, if you missed something, or double quotes, or if the spelling is wrong, instead of printf, if you just type print, you see an error message. But here you don't see any error message. How do you tackle this one? Where will I know that I have done something wrong in my program? Okay, for this you cannot ask NetBeans or any of the IDE. You have to go to the place where it is showing. So in the browser it is showing. You have to ask the browser what is wrong with the my JavaScript. So how do you do that thing? Remember the shortcut, keyboard shortcut for this in most of the browser, the keyboard shortcut is F12. I'm not going to type that F12 in my video because you may not be able to see that F12. So what I'm going to go here is almost all browsers have this 3 ellipses here on the other side, that if you click you are going to get the menu over here. So you go down and you get more tools. In almost all you get this more tool, and in this you get this option as developer tools. Okay, so you are going to get this one. Any browser you take it, you will get the developer tools. So you go and click on this developer tool. Now when you click on this developer tool, you are going to get some error here. So always go to the console. Remember it some of them may show it here at the bottom, some is showing here. In this case it is showing here. It depends on the browsers, but what you are supposed to do is you are supposed to go to the console. Click on this console and you will see what is going wrong with your script. Now if you look at here, okay, I'm going to just zoom out. Okay, it says ANGLE is not defined, so you get an error message. Okay, so if you click on this, or if you click on this, it's going to show you where that thing has happened. So it's going to show you. So ANGL, if you look at here, I typed a spelling mistake. So there is a spelling mistake. and that is what it is saying. You done a spelling mistake, I can't get that thing. Then once you completed everything, completing this part, you just click on this X mark and it's going to close. Okay, that's as simple as that, you know very well. So here, if you notice, I have made a spelling mistake. Instead of A-N-G-L-E, I type A-G-L something. Okay, so I'm going to save it now, and you see the effect now. Let me go back. Okay, this is what you are going to get. So you may say that that is not a clock, but you got something from here. So from here you got a different connection here. But what is done over here is you don't start from the center. You don't start from the center. You start somewhere here. From here to here. From here to here. So from here to here, don't start at the center. That is what they have done. They have not started at the center. They have started somewhere after that center, somewhere near, like the 80% to this one. So they have left this 80%, they have left, and then they are drawing it here. So rather than starting from the center, they are leaving something like 85% or 80%, and then they are drawing the arcs there. So let's try to do that thing. So we are going to define the length of our the markings. So let's say constant, and I'm going to say length is, I'm going to say 80% of the radius value. So what is this radius that I have? So radius is this radius into say 0.85%, 85% of this thing. I'm going to draw the marking. Okay, so let's save it and let's see what is the effect. Let me go here, and what is the by the way, I have not taken, I just made a length here. Now I am starting at the center. So instead of center, I'm going to say don't start at the center. So start slightly towards this 80%. Remember, I cannot simply add this 80%. Remember, if you, I hope you are able to get it. If you simply add it, it's going to be the 1 point. If you just add that 85%, this line may start from here to here, but all the lines are not straight. Some of them are angled. So you must take care of those angles also. From this point, it has to go. So these angles that you have used, that also has to be taken. So don't just say that you are going to add plus this length. No, it is 85% length. You can do that thing. You have to, that inclination, so called, if you have this circle here, this inclination has to be taken care. That how do you take care of that inclination is because of that theta, cos theta, sin theta, whatever you have. So plus inclination plus that value. So you have to take that. So I'm going to say plus, okay, math dot cos theta, you know very well, math dot cos theta, so cos of the angle, that is cos theta, into that length, whatever I have taken. So inclination plus that length. Why this cos theta has come? Because in the circle you have to take care of that angle theta. This angle has to be taken care, that theta has to be taken care, then you have to get this lines or anything for that matter. So I'm going to say again for this also, math dot sine sine of the angle into the length. So done, and I'm going to go here and let's look at C. It's gone. So it is now starting from here. 85% it is starting, 85% it is starting, 85% it is starting, 85% it is starting. But if you notice that this is slightly lesser than that, so I'm going to just make it as 95%. Say, let's say 95%. Let's fix it at 95%. And if you go back, you notice the very dots are there. But there is one other minor problem. What is the minor problem? You know very well, at 5 degrees, you have 5 minutes. After this 5, you have 10 minutes, then 15 minutes. So for the multiply of 5, all the multiples of 5, 5, 10, 15, 20 and so on. So every time you are, if you look at the width of the height of it or the length of it, it is larger than the this one. All of them, all these small tiny things are 95%, but this is there at say 85%. This is there at 85%. So we have to take care of that. How do we take care of that? So I'm going to go here. The length of the is not just 95%. What I'm going to say is if the value of I is divided by 5, okay, so if you get the value of I, that is which is divisible by 5, so this is 5 is divisible, 10 is divisible, 15 is divisible, 20 is divisible, and you notice that 25 is divisible. For them the length must be different. Okay, so if it is divisible by 5, I'm going to use a 3 equal sign. You know very well what is the meaning of saying 3 equal sign. You've studied the JavaScript now, so you know what is a 3 equal sign. So if it is 0, then radius into 95. Okay, otherwise it is radius into 85. So in other words, I am going to change the value of this marking depending upon the divisibility. So if it is divisible, it's going to be say 85, otherwise it's going to be 95. So for this all divisible by 5, okay, all divisible by 5, it is 85. That is length must be larger, otherwise it must be smaller. So let's look at the effect now. You notice that it has come there. Beautiful, it has come there. Only problem is you notice that it is a sharp edge is there. So if you look at them, they are all sharp edges are there. I want them to be curved edges. So how do we go for the curved edges? If you look at here, this is curved edges. How do you get to go for this curved edges? So to do that, we are going to go and we are going to give one styling, and I'm going to go to the context and I'm going to say line cap, that is the end of the line. So line cap is equal to, I'm going to say it is round. Okay, done. Let's look at the effect there, and you notice the effect is good. Okay, however, again you have some other problem. You notice that if you carefully observe that these 5 marking are there, this 5, 10, 20, all of them, their width is slightly larger as compared to this marking. So as compared to this marking, their width are slightly smaller. So again, I'm going to take care even of that one. So let's go and let's go here again, same thing. I'm going to say if it is divisible by 5, again I'm going to use 3 equal to, then it is the width is slightly higher, that is 8, otherwise it is 6. So let me save it and let's look at this effect now, and you notice that this is thicker, these are thinner, this is thicker, and this is, so if it is divisible by 5, then it is thicker, otherwise it is thinner. Okay, so we are able to get this part. Now our next challenge is to get a circle, a hands from here. So these hover hands, the minute and the second hands, all these hands has to be drawn. So I'm going to use first of all, let's get this hand position. So where is this position? It is coming to 10 o'clock or something. Where is the position? That's very important thing, how to get the position. So I'm going to write a function. I'm going to just write a function here, and I'm going to say draw the clock. Let me start with the function. Draw clock. Okay. This is going to be my function, and I need the hour, minute, and second, right? Is it not? In order to draw that, I must know what is my system time. Without that, I may not be able to get it. So how do you get the system time? You know very well. It's the easiest way to get your system time is to go and ask the date. So let me create a constant. Let me say what is the current time? What's the time at now? So how do you do that thing? I'm going to get a new date. So this new date is going to give me the date with the time, the current time. Whenever you call it, that second it's going to give me that one. From this, I'm going to get the hours. How do you get this hours? So you are going to say hours is equal to now dot get hours. Okay, remember this is a 24 hours clock. You know very well all these clocks that you see here, the one that you see here, where is that window gone? This clock that you see over here, these are 24 hours clock, but our analog clocks are 12 hours. These are 12 hours clock, so we have to divide it and get the 12 hours equivalent. So I'm going to use mod division so that I get this 12 hours value. Not 13 hours cannot be represented in an analog clock. So this clock does not have 13 hours. 13 means it is 1 o'clock. So again it has to come back. So I'm using this one. Let's go with the next one. What is this? This next one is the minute. Minute is now dot get minutes. Remember, there is nothing wrong in this one. Again, I'm not going to divide it by 12 because minutes are 60. Whether you are using this clock or whether you are using this clock, whether this or this, both of them minutes are 60 only. So you don't change the minute value. Again, same thing. Let's go with the seconds. Okay, so seconds is now dot get seconds. Okay, so what is the spelling? Seconds. Done. You got minute, second, and all of them. Okay. And then let's get to the position. So based on the hour, minute, and second value, you have to adjust the position of the hour clock. So position of this one, position of this one, and position of this. So the hour hand, the minute hand position, and the second hand position has to be based on those values. So I'm going to say one more variable. So hour hand position. Okay, position of the hour hand is how do you get that thing? So you have this hours, no doubt, plus if any fractions of minutes are going beyond 60, so divided by this. Why did I divide this by that value? Okay, you may say that why you are dividing it. Remember, when you are having, so suppose this is coming to the 10 o'clock, this is 10. Okay, but at 10:30 the hour clock will not be here itself. Our clock has to go somewhere here. At 10:30 it has to reach in the middle. So 10 plus how many minutes it has traveled. Okay, how many minutes? Based on that, the hour clock will shift from here to here. So this minutes has to be taken care. If you just take 10, it's going to stay here itself. At 11 o'clock, it's going to stay here itself. 11 plus how many minutes it has traversed. That has to be taken. So based on that, the hour clock position must be somewhere here, here, or closer, or farther, depending upon the value of this minutes. So this minutes has to be taken care. So remember, you can't just add direct minutes. You have to add the fractions. The reason is if you add minutes, it will be 54. So 10 plus 54 will be outside the clock altogether. So you don't have those much hours there. So divided by 60. So that fraction that you see here, this fraction is 10 o'clock plus some fractions. That fraction has to be taken care. So I've taken that particular thing. Now the question is, what is the angle? So the next question will come here is, what is the angle with which the 10 o'clock or 11 o'clock or 12 o'clock, whatever it is, moving? Okay, that angle has to be taken care. How do you get this the thing? Now in the entire circle, how many degrees are there? You know very well. This is 360 degrees are there. You know very well. Entire circle, 360 degrees are there. How many markings are there? So how many markings are there? You know very well. So 1 o'clock, 2 o'clock, 3 o'clock, up to 12 o'clock. Divided by 12. So what is the answer you are going to get? 360 divided by 12. So what is the answer you are going to get? Where is my calculator? So my calculator is here. 360 divided by 12. So what is the answer? 30. Okay, so this is what I want to get to that. So in our case, what is 360? 360 I have already told you. This is 2 pi. 360 is 2 pi. 2 pi radians is equal to 360. Yes, sir. So you are dividing 360 by 12. In when it comes to the radians also, you have to divide it by 12. Okay, 2 pi is 360. What is pi? I have already told you. Pi means half of 360. 2 times pi is 360. Pi means 180 degrees. Okay, so if you are dividing it by 12, so 2 goes 6 times here. Okay, you can say cut it and so this is pi by 6. In the same way, you can say 2 goes 2 times. 2 goes not 2 times, it is 180 times. Okay, and this 12, 2 divides it by 6, so 180 by 6. Okay, so pi by 6 or 180 by 6. I'm going to use this one for my calculation. So this is the angle. So this that 1 o'clock that you see, this 1 o'clock timing that you see, that 2 o'clock timing you see, all of them are divided at pi by 6, that is 180 by 6, that is 30 degrees. So from, we go here, from here to here, what is the angle? So let me draw here. From here to here, what is the angle? The angle is 30 degrees. So this is 30 degrees. From here to here, what is the angle? The angle is 30 degrees. So this is what I want, not 30 degrees. Okay, from here to here, so every time it is 30 degrees. Okay, so whatever value is, whatever hour is there, from 10 o'clock, if you want to get this 10 o'clock, this is 30 degrees. From here 30, 30, 30, 30, you multiply 10 times, you multiply, you get that much, 10 times 30. Okay, so 10 times 30, because 1 division is 30, this is 30, this is 30, 30, 30, 10 times 30, you are going to get it. So whatever value into pi by, I'm going to say into math dot pi by 6. Remember 360 by 12, or that is 2 pi by 12 or pi by 60, it's up to you. Just for brevity, not really required, I'm going to put a circular bracket. This is the BODMAS rule. We follow this BODMAS rule. What about the minute position? How do you get the minute position? Again, same story. So you start with the minute hand, okay, plus any fraction that is left, the fractions of seconds. Remember, when it comes to the minute hand, if you notice over here, minute hand is slowly moving. This is also has to move depending upon the seconds, it has to move. Okay, so minute plus any extra seconds that may be there divided by 60, that is a fraction of second. So minute is not just staying at 10 o'clock, a fraction of that. It is, you notice that it is slowly moving there, that fraction is there. So this fraction that has to be taken care. Now the question is, how much does this minute has to work? Okay, so in a circle, let's start with the story of this circle. Hours are 12, so you know very well. The whole entire circle is 360 degrees, you know very well. So in the circle you have 360 degrees. But how many minutes are there? How many minutes locations will be there? So there is going to be, if you look at here, there is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 60 minutes will be there. So in the whole circle, there are 360 degrees are there. What is the 1 degree? So between this and between this, what is the angle? Okay, this is 360. Remember, there are 60 markings are there. 360 divided by 60. Those many markings are there in the circle. Okay, so these many marking will be there. So what is this 360 by 60? Okay, let's look at this in the calculator. Let's go to the calculator, and I'm going to clear this one, and I'm going to say 360 degree divided by 60. What is it? This is going to be 6 degrees. So this you can directly multiply. Remember, you can directly multiply if you feel like why you are taking pi by 2 and other thing. So 1 and 1, this one difference, not this one, one small, I have to draw it like this. Okay, this is the 30, the degree that you've taken. What is the degree? 6 degrees. Okay, that you've taken, that is 360 or 180 by, see, remember 360 by 60 or 180 by 30. It's one and the same. Okay, 6 degrees. Okay, so I hope you got what I am doing. I hope you get this. 360 degrees are there in this circle, divided by 60. Okay, or you know very well, 180 divided by 30. The ratio is same. Okay, why? 2 goes 18 times, that is 180 times. 2 goes 3 times. Okay, so or 18 by 3, or you just multiply it with the 6. It's up to you during the examination, whichever. If you know it, you just do it. If you don't know, go for the longer one. Okay, what is 180? 360 is 2 pi. You know very well, 360 is 2 pi. What is 180? 180 is just pi. So pi by 30. I'm going to go with the pi by 30. Multiplication factor is pi by 30. So let's go ahead and let's start with the math dot pi, okay, divided by 30. Okay, so this much fraction it has to go. Okay, it has to go a fraction. Can you see that it is going by fraction? Let's go with the next one. Okay, and that is what is this one? And what is this? And this second position. Okay, what is it? Second position is very simple. Whatever seconds are there, you don't have anything beyond this seconds into. Okay, same thing. How many divisions are there? How many seconds? How many positions are there for the second? You know, same as the minutes. Okay, second is going faster 60 times, but a minute is going slower. That is simple. But it is going. It is taking 60 stops. So it's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 60, 30, and finally it's going to reach the 30. So it is going to be the same story. I'm not going to explain the story again. This is going to be the same thing. Pi by 30. You got it. Now we have to draw this thing. So let's write one more function. So one more function. I'm going to say draw, and I'm going to call this one draw hand. Okay. This draw hand that I'm drawing will take a few parameters. What are the parameters? First one is the position where it has to be drawn. Okay, that part it is taking. Second one is the length. Now you may ask, what is the, why do you are taking length? See, the length of this and the length of this are varying. Okay, the hour hand and the minute hand, the length are generally, you notice that the length is varying, as well as the width is not width is changing. So you notice that the width of this is, it is thicker, hour hand is thicker, the minute hand and the second hand definitely is very very thin. Okay, so you have this many things there. Now as usual, what are you going to do? First of all, we are going to set the length and the width there. So because we have to draw a line, I'm going to say ctx dot line width. So I'm going to say line width equal to the width that is given to me. Okay. So line width is same, and needless to say, remember this. Don't have to do it. This is not straight. It is. If you notice that it is curvy. How do you get to this part as curvy? Is line cap. So I'm going to just set that thing there, so that I don't have to. If I forget it later, I may forget it later. So round. So that ending part of the line is not straight. It is like a cap like thing. It is curve like thing. Okay. And let's set the color. And you know very well this color is black in color. So let's set that color ctx dot stroke style. Let's say it is black. You know, done. Now let's start drawing it. So ctx dot, we know very well, to start we have to say begin path. We have to start with the path. Now the question is, how do you get this angle? Okay, so to get the angle, you know very well, it is the simple story. You say that the old style, what is your old style? You say math into length and this one. The last time you did this one, is it not? Let's try to put this one and let's see what's going to happen. So you know very well, any position on the circle, where is it gone, is given by cos theta and sin theta. You know very well, r cos theta, r sin theta. The same story I said, the r into the length, this is into the length. You get the position. By the way, I have to move to the center of this one, not to this one. I copied this wrong thing. Let me make it. First, let's move to the center. Okay, last time what I have done, let's move to the center, and based on the, where is this? Based on that, I'm going to just for understanding how it's going to work. So I just copy pasted it here just to see whether if I do it, I'm going to get the hour hand. Okay, will I be able to get my hour hand? Okay, so let's call this one. Remember, I will not call this thing again and again. So I'm going to call this function, that is draw marking. This function, not this one, the first one that I told you. I'm going to call it inside this clock itself. So inside this clock, I'm going to call the draw mark. Where is this gone? Just give me a second. I'm going to call this one, this draw marking. I'm going to call this one directly inside the draw clock, so that I have to just call this draw clock function. So I will just call draw clock function at the end of the script. I'm going to just call this draw clock function. Okay, this draw clock function will ultimately call draw marking function, that is this function, and then you are going to show the hand. So will you be able to show the hand? Let me save it, and if I refresh it, we'll be able to see that thing. Now if you are not able to see the hand, let's go and let's look at where is it gone. So more and developer tools, to see whether I have done a mistake. So the hover is not defined, so you notice that hover is not defined. Where is this hover? So there is hovers are there. Hovers is there. So somewhere I have done hovers should be there. So this is hovers, and let's say this I have taken as, let me make it as minutes. Also this one also minutes. Okay. So this is done. Now there is no error, but you still not be able to say there is. If I go to console, there is no error. Forget about this error. Why I am getting this error? So you may say that one is I have this Kaspersky antivirus that is running, and it is trying to do something. And the other one, what it says is you don't have fav icon. This icon is not there. It's not required for me. So if it's there or not, I don't care about it. So if it's giving me some that one, so it says the fav icon is not there. You know very well this icon. You see one icon. If you go to Flipkart or Amazon, you see a different icon there. That icon is not there. It's not there. It's not required for me. Okay. So whether it says or not, I'm going to say when I say Kaspersky, it just came. Okay, to remind me that it is there. Okay, so let's go ahead and let's fix this problem. Why it is not coming? Because I have not called that function. If you are wondering why it is not coming, why sir it is not coming, because I have not called this draw hand function. As simple as that. So let me go and let me go to the hovers position. So I kept this hover position, and I'm going to call this function draw hand, where I put all this effort, that whatever effort I put, that function I am not calling it. So what is the first thing? First I have to specify the position. That is, where is this? First I have to give the position, the length, and the width. So let's give the position. The position is, first one is for the hover hand. Okay, hover position. Okay, what is the length that you can expect? Now you can specify any length of your choice, but I will not give any length. Remember, if let's go to the sample here, this one is shorter, this one is longer, this one is also longer. So I'm going to set the shorter. How do you get the shorter? Remember, you can't just give it in pixel. It is the radius into 70%. What is the meaning of saying 70% of the radius? And the thickness I'm going to give it as a 10 pixel. This is for the hover hand. So hover hand is shorter, but it is thicker. Hover hand is shorter, that is 75% of the radius, and it is thicker. That is done. Okay. What about the minute hand? Minute hand is say it is slightly longer, 0.9 let's say, and it is thinner than the hover hand. Done. Let's go for the second hand. Second hand is maybe still lesser than that. Okay. I don't know, and it is still thinner. Okay, done. Now this one is not. Where is this one? This is second position. This is second position, and this is not hover position. For us, this is the minute position. First one is for the hover position, second one is for the minute position, third one is for the second position, because we have to put the all of them. So if I go here and if I look at here, I get an exception. Let's see whether I get an exception or not. Okay, I get an exception. Angle is not specified. So where is this? Angle is not. Cos of this angle, it just says that angle is not specified. So it is not getting this angle. Let's see why it is not getting this angle. Let's go and let's fix this problem. Angle, it is not getting this angle. What is the reason? So I have not specified this the angle that I was supposed to specify the angle there, but now it is saying that you have given the angle there, okay, but that angle is not there. It says the answer is yes, it is not there. There is a draw there. Okay, this angle is not there. Instead of angle, I am using the position. So I have calculated there. Remember, it is 30 degree, it is 6 degrees, 30 degrees, that angle I have specified, and I copy pasted it. So this is not the angle here, this is the position. Okay, so that's the position, just the position. Save it. Okay, let's go back, and you got the thing. Okay, however, very interesting one. Now, if I call it again, it's going to move. If I call it again, it's going to move. Okay, call it again and again, it's going to move. Okay, I have to call it regularly, I have to call it. But the problem is, it is 10 o'clock now, but it is showing 1 o'clock, right? But this one is showing 10 o'clock, that's proper. But our clock, it is showing 10 o'clock. But if I call it again and again, okay, I'm going to call this again and again. Let me call that again and again and just show you. How do you call this again and again, this function? You know very well. You have to set interval. So see, you are calling it only once. This draw clock is there. You are calling it only once. If you want to call it many times, you set the interval. How long it, how within that interval it has to be called. So I'm going to say set interval, and I'm going to call this a draw clock. Okay, and I'm going to say within 500 milliseconds, just call this draw function. So it's going to call it every 500 milliseconds, it's going to call it again and again and again, the same function it's going to call. So instead of me refreshing it again and again and again, it's going to call it. Now you notice that it is moving. Very well and good, it is moving. First of all, this clock is not properly adjusted, but it is moving, but it is showing the traces. What is the reason? Because when it is moving, it is not clearing the image, that the background. So let's go and fix that problem. We will come back to this major problem later. First we will solve this chota problems which are coming over here. We will go here before drawing this marking. Yeah, that is before drawing anything, before drawing this marking or anything, we are going to clear that rectangle region, this rectangular region that we had, this whole region which was there. We are going to clear that whole region, and then we are going to proceed. So let's start with the CTS, and I'm going to say what I can say is clear rectangle RECT, okay, starting from 0, 0 till the width and height of the clock. So I'm going to say CLOCK dot width and CLOCK dot height. I'm going to just clear that thing so that it clears it every second. Is going to clear it. Okay, so let's look at it here. Now you see that it is not showing the traces, but the major problem is still there. What is the major problem? Major problem is this thing. What you notice here is not the same as this thing. That not this, it is coming in red and black and other thing. The time itself is not proper. So what we are supposed to do? Okay, so let's look at the story. Yeah, so let's look at this story. So when you have, let's start with this one. When you have this, you know, well, this is 45 degrees. If I draw this line, this is 45 degrees. Okay. Below this, if I draw, this is 30 degrees, 20 degrees, and so on and so forth. Okay, so when this line touches here, this is going to be 0 degrees. Okay, so you know very well. So let's go. Where is the mouse point? Okay, so this one at 0 degrees, that is 0 hours is 0, hour position is 0. So at 0 degrees, where is the hour clock must remain? That at 0 means 12 o'clock is the same as 0. At 0 degrees, where must be the hour clock? What is the position of the hour clock? Hour clock should come here, not at here. Our clock is drawing at 0 degrees. Our clock is drawing here, 0 degree, but that is why it is going forward. See, instead of putting it here, it has shifted by 90 degrees. So if you look at the original time, What is the original time? 10 o'clock. 45 degrees it is shifted. You notice that it is shifted by 45 degrees. Okay, so our clock, I'm sorry, the 90 degrees it has shifted, not 45. The 90 degree shift is there. So when we say 0, that is when we say 0 degrees, our clock it is supposed to come here. Our clock it is supposed to, the hour clock must come here, not the at this, but our clock is going to come here. What to do then? Compensate for this one. So what is the compensation? What you can do? Okay, that is the next question. Next, the answer is very, very simple. You don't need to think much on this one. This is gone, I suppose. Okay, whether I'll be able to get to this one. I just removed that one. Now let me start with this one itself. Okay, you know that see, my clock has to come. So this is cos theta. Okay, x degree is cos theta, and y, this is sin theta. So sine is 0. That is why it is come here. Okay, when it is coming here, sine is 1 and cos is 0. Now look at the problem here. This is cos theta. Cos theta, it is coming here. But what is that? I want my clock has to come here. My hour has to come here. So I want this value to be 1. The y-axis value to be 1, so that it comes here. But what is the y value at 0 degree? It is 0. Okay, so why it is 0? Because this is given by sine theta. Okay, this is given by the cos theta. But look at the difference here. One that is given by the sine theta, the other this is cos theta, other one is sine theta. So if you use cos theta at 0 degree, cos will be 1, sine will be 0. But this is not what I want. What I want is I want this value to be 0, next value to be 1. So what should I do? This value at 0 degree, this is given by cos. Okay, this is given by sine at 0 degree. Okay, if I use cos and sine, I will reach here. But if I interchange the cos into sine and sine into cos, what's going to happen is this 0 is going to come here. Okay, and this 1 is going to come here. When this 0 comes here and the 1 comes here, your hour is going to come at this position. So in other words, what I want to say is, even though whenever we draw any point on the circle, we say this x value is cos theta and y is sin theta. That is good. But for us, if you do that, we will shift by 90 degrees. So what we are doing is we change the cos value here and we change the sin value here. So cos and sin values are interchanged so that that 0 and 1 compensation is being done. Okay, so I'm going to go here to my drawing story over here, and where I'm drawing this hand. So I am going to say, instead of cos theta, okay, I'm going to use sin theta. Let me put this one here and let me get it to the other one. So I have interchanged cos and sin value. So in my previous case, I used to say x cos theta and y sin theta. But now what I'm saying is x sin theta, y cos theta. So these two values are interchanged so that you are able to compensate the clock. Now, if you just say, okay, I'm going to do this and I'm going to see what is going to come. Okay, if you see this one, okay, you notice that it is doing worse than what you expected it. What is the problem? What happened? You may say that, see, what sorry, you told all these stories, but when it is trying to draw, it is drawing something which is absurd. Okay, now it has gone to your story, whatever you told that story. If you say It is doing something absurd. What to do? Okay, what is the solution for this one? The solution for this one is the problem with the y-axis, y coordinates. Okay, it is moving in reverse direction. What to do with the movement of reverse direction? What should I do? Now, first of all, I copy it? Okay, so what is the problem? Let's come back to the story again. Okay, let's come back to this clock if it is there. See, if you notice here, as your clock is moving here, here your pointer is moving here and here, y value, y is initially 0, is changing from 0, it is changing to minus. Okay, so that means to say that y is constantly decreasing from this length. Y value keeps on decreasing 0, 1, 0.5, 0.8, 0.9, 0.8, 0.6, 0.10, so, and finally it becomes 0. So y value should decrease from the initial value. Y should decrease and come back to 0. Okay, but what is that we are doing? We are adding the value to the y. You notice that we are adding the value to the y. So what are we supposed to do then? We are supposed to subtract it, that's all. Instead of adding, you subtract it. Remember, when you add it, what is going to happen is y value which was initially this, let me do it one more time, y value which was here, it keeps on increasing. I want the values to be subtracted from here. Slowly it has to come down. Okay, so I'm going to subtract this y value. Save it, and let's see what is the effect. It is moving. Yes, is it moving? Well and good, it is moving. And let's look at our clock. Look at our clock. This is, look at this one. It is somewhere here and somewhere here. Yes, look at our clock. It is somewhere here. No, it's not coming properly, no doubt about it, but it is coming there right now. It is almost, we are there at that location. Okay, but the only thing I am worried about it is I gave the length as 70%, but somehow it has not come to 70%. Let me just the value, why it has not taken it as 70%. What is the reason why it has not taken 70%? So let me go back and let's check. Oh, so this I am multiplying it with the radius. So just a minute. So this I have not used that length at all. This is the length. That's why I was wondering why it is the length of this is same for all of them. If you look at here, the hour, minute, and the second, everybody has the same length. That I was wondering what is wrong. So I am supposed to multiply it with the length, not the radius. If I multiply it with the radius, all of them will get the same thing. Let me save it. Sorry about that. Okay, now you see this hour and minute, and you see this hour and minute. Everything is good. You got the clock, but one minor problem. What is one minor problem? You see this clock. There is some extra tail for this. There is some extra tail for this. Your clock is ready, but there is extra. Oh, this we are not taken care. So our clock, we don't have the tail. Now, how do you get the tail? Now, to get the tail, you have to draw one more line. That's it. This line you can't go back and get it. This is extra line. This is extra line. This is extra line. So you have to go slightly below the x-axis. So don't start at 0. Slowly go below this x-axis and come back. So go slightly below x value, reduce the x value, and then get it from here. Okay, we are going to draw a separate line there. We are not going to use the same line there. So how do we get that thing? So I'm going to start with the story there. So I will draw one more line. I'm not going to type this whole thing. To draw this line, you are doing this. So I'm going to just copy paste it. So I'm going to draw this next line. Again, this next line will start at the center. It will do the same old thing, but its length is minus 3. I mean, division by 3. I'm just reducing the size of it. What is this? What is this? You said, if you ask this, what is that you're done, sir? I don't want this thing to come here. Okay, come up to this point. I don't want it has to start slightly down. So it is what I'm saying is one third of this value. I'm taking it back. How do you take it back? X value has to be reduced. You have to take it back along the X direction. So I'm going to reduce this X value. Okay. What about Y value? Remember, don't take Y value also back. Let's increase this Y value. This time it is not, it has to go in the other direction. You have already seen last time when I made this one as plus, it was going, when I made it Y plus, it was going in the other direction. So let it go to the other direction, no problem. But X value is slightly lesser. Okay, so let's do it and let's see the effect now. Where is my clock? Can you see the clock there? Okay, it has gone back slightly back with one third of this height. So this height, what you've taken is one third of this height you've taken. Done. Okay, now there is one other problem, and the other problem that you said, if you think that we have done everything, we have not done. You're not done with the work. What is that? It is coming again. What is that we have not done? We need a circle here, and this particular thing, if you notice that this thing, what you notice here is a very different than these two. They are not the same one. So I'm not going to write this whole thing again. What I'm going to do is this function, the function which is doing its work, no doubt. I'm going to copy this whole function, Control C here, this whole function, draw hand, this whole function. I'm going to copy it and I'm going to paste it again. Okay, function two times I have written this function, draw hand. Second one is draw hand second. I'm going to just make it as draw seconds hand. Let me just say draw seconds hand. This is specific for the second hand. Okay, so I'm going to say draw second hands. So I'm going to just copy this one, double click, Control C. When I'm calling this second hand, you see this second hand, so second position, I'm changing it, and I'm saying that for second hands, for this second hand, you call this method, this different one. So these two, draw hand is for the two hands that you have. This is hour and minute. For second, the color is different, as well as there is one other cap and other story is there, a lot of things are there. So for the second hands, same story, same as the previous one, but only thing is your color is changing as a red color, and it is having some other extra accessories. So I'm saying that for second, this is the function. So for the second, this is the function, and what is this function? This is the same function, but this time slightly different. Let's start with the first. Let's start and change the color as red. So if you look at this one, let's go to the other one. It is red in color. So you got the color is red because other two are black. This is red. Then let's go and let's fix the other few other problems. So what are the few problems that you face? First of all, you need a circle at the center. You need a red color circle that is required. Okay, how do you get to this circle? You know very well. You have to draw at the center. If at all you want this red color circle, you have to draw a circle here, right at the center. You draw a filled circle. Okay, you draw a filled circle here, right at the center, and your story will be over. So let me go to this one. This part I'm not going to touch. This is same as the previous one. I'm going to add extra thing here. Okay, how do you add the extra thing? We will start with the begin path. Okay, let me say begin path. I'm going to just copy these two lines there. Begin path. This is same, and I'm going to say ctx. Ctx. I think color is already there. Let's say I'm going to say fill style. Okay, so I'm going to say fill. I'm going to say I'm going to say fill style. So this is my fill style. So let's say fill style. Style is red. Okay. So this is my fill style is red, and I will not move to any position and other thing because I just want to draw a circle. So ctx dot, let me remove this one. Ctx dot, you know very well how to draw a circle. You have to draw an arc. Okay, start at the center. What is the center? Cx and cy. You know very well, we have started with the cx and cy as our center. So at the center, okay, with a radius of let's say 10, okay, at an angle 0, you draw the circle. How do you draw the circle? So circle, you know very well, 360 degrees. So you say math dot pi into 2. So 2 pi radians, okay, you say that. And to complete this whole thing, you are going to say ctx dot fill, and that's it. You just have the circle here. You got the circle right at the center. Okay, done. No, that's not the end of it. You have one more circle that is coming here. So let's fix that one. So this part is done. Let's start with the filling the circle with the stroke. Remember, this is not a filled circle. First thing, where is this? This is not a filled circle. It's a stroke that is coming here, and it has to come. If you notice over here, it has to come at the end of this thing. It has to come. This is the end of here. It is coming at the end of this line. So we have to go to that line and then draw the circle. The story remains almost the same. So I'm going to just copy this one and paste it here. Okay. So we start with the red color. Okay. We need we have to draw this arc there. Okay. So we have to draw this arc there. So we can say there when we are drawing this the arc, we can specify the width of this arc. So ctx dot, you can say arc, not r, arc, that is the circle that we are drawing. So the arc width must be same as the width that is given. Okay. So when we got it, we got the width here. Remember, the arc must also have this thing, must have the same width as that of this. If you change the width, this arc must also have the same width. So I'm setting the arc width as that one. So we have set the arc width, and then we have to go to the center, not here. We have to go to the end of this particular line. How do you go to the end of a line? To go to the end of this line, you know very well, you have to specify this thing, that is the, we go to the position and then the x value. So you go here, position and the x value. This is going to take you to the end of the x value. And what about the end of the y value? You know very well. If you know that how to go to the end of x value, you can always go to the end of the y value. So this one is the end of the y. So this is going to be the end of the y. So this is end of x, end of y, and we are drawing one circle there. So simple as that. However, there is one minor problem here. I don't want it to be filled. I want a stroke to come. You know what is the meaning of saying stroke? And it's not the heart attack stroke that you are drawing. where am I doing it? Okay, am I doing it? Okay, it is the what to say the line, not the filled circle. Okay, so don't get confused. So we are there at that thing. So where is my thing? Okay, go on. Let's hear. You see that it is coming. It is coming, no doubt. Okay, but it is not same as this one. Why it is not same as this one is that line, end of the line. Can you see this end? I told you that circle is drawn from this. Okay, that's why that length is coming. So now I have to fill this thing, whole thing, with some color. So which color? Definitely white color. So this, if you notice here, they filled it with the white color and then they are drawing it. So the whole story is same. You have to draw the circle, no doubt. But before that, you just clear that area. So before drawing, so before you draw something, you just clear this area with white color and then you draw it. So that that one line that you see there, one extra line that is coming, that is not shown. Okay, what to do? In the machine, it is easier. You just copy paste it and then change the color as white. So simple as that. You know how to draw a red colored circle here. You know how to draw a red color. This is a stroke, but you draw the same thing but with the white color. So simple as that. So I'm going to just copy it, just go up and then paste it. So this is before it should come because we want to clear it. The color is white, you know that white, but the arc width may not be required at all because we are not interested in the drawing an arc, because we are not going to draw the arc. But what is that we are going to draw? We are going to draw a filled white circle. So we will not say for this white, we will not say it is stroke, it is fill. Okay. For the red color, it is stroke, no doubt. For this, it is a white color. So we go here and you see that this is cleared with white. First, it clears it with the white and then it draws it. So now you can see the effect. Now, one thing that I have just told you, what happens if you set the value of this, where is this? Let's go to the first story from where I started. Instead of here, instead of this, what if you set the style? So if you go here and if you set, say, width, if you say width equal to, where is this? Why it is not showing width? Width equal to 400 pixel and height equal to 400 pixel. If you say, and then if you come and see, this is what you're going to see. So remember that if you during the examination, if you get this kind of thing, this is because that whole thing is not fixed. You are not fixing this. The width and height has to be there for the canvas itself. When the canvas is drawn, it should come there. It will not take these values if you set it for the, what is this, in the style sheet. So if you set it in the style sheet, my machine is down. Okay, so if you set it for the style sheet, it's not going to work. So I am going to delete this one. Okay, don't do it for the style, do it for the canvas element itself. I am getting some problem with my mouse. Okay, so let me do it with the canvas itself. I'm going to just paste it for the canvas. Remember, if you get that thing for during the examination, you set it at the wrong place. It is no doubt you are setting the color and other thing, I mean the height and width properly, but you will not get this effect. So always set it for the canvas itself, width and height for the canvas itself, not make it as a style sheet. Don't put it on the styles, don't put it on CSS, you won't see the effect. Okay, this is what they have said. This is what they have said. Get the thing. Okay. If you want, you reduce the size. If you feel like no, this is too much, go for 200 and 200. So just save it, and your clock will come like this. Okay, the one that they have shown. I don't know, 300 maybe, something. Okay, I'm not wasting your time on the video with the uh, color and this adjustments. Okay, somewhere you can see this one, that is the effect. Okay, that's all in this video. We will meet again in the next class. Thank you for your interest.